So, about 3 years ago, I was inspired to build my own power hammer and get back into blacksmithing. And this is what I came up with so far. The spring is sitting over there. But the first thing you really need to do, I found, is to do your math. You need to figure out some equations here. Length times width times height equals your volume. And then you want to multiply your volume by your density. And you will get the weight. So the weight is really important because from what I've researched, this is just all on the internet. Minimum is 10 to 1. So your hammer has to be 1/10 of your total weight. If your hammer only weighed 10 pounds, you would only need 100 pounds underneath it for efficiency. But this one's more, I think it's closer to 20 to 1, which is more recommended. So, we have our equation. Now let's talk about our round stuff. This is our post. Your volume equals pi times the radius squared times your height. And we're doing this all in inches. .284 pounds per cubic inch. That's just your common mild steel, from what I know. It's either 284 or 283, depending on where you look. So we need to figure out how much this thing weighs and how much our hammer weighs, which I already did, so we'll skip through it. Our radius is 2.625, which is 2 5/8. Yep, 2 5/8. So multiply that by 2 and you get your diameter. But then you punch it into the equation with your height of 21 inches. So you know your radius and your height, and you can do all the math. And that came out to weighing, I think, 129. Yeah, there it is. I wrote this down the other night and I didn't double check it, so I hope my math is right. Excuse me if it's not. 129.56. So then we have to figure out all of our I-beam stuff. Oh yeah, this is an I-beam. You can kind of see it there. The bottom frame is an I-beam covered with a piece of 7 gauge. I did not include the 7 gauge in the equation. And that comes out to 114. And then we have the base. And there's my math for that. It's 2 inches thick. It's 2 1-inch plates I welded together. And that's not optimum. You're going to lose some energy because they're not touching great. But I did trim a little between the two to get them to fit better. And clamped it really well when I welded. So that's 284 pounds. And run everything together. 527 pounds. And that's without the top. There's a top piece that holds the spring to my right. So that will add more weight. The spring will add more weight. And we have the hammer. 24 inches by 2 inches by 1 3/4 inches. And we're just under 24 pounds. So 527 for the body and 23 pounds for the hammer. That doesn't include the die mounts, the dies. There's a piece of 4140 that will mount on top of this. Excuse me. And I think that weighs about 25 pounds. And the die plates will bolt down. There's the holders, the shims. The die material itself, that's more 4140. That's going to be welded to some 1/4-inch plates. And then we're going to cut a hole right where that anvil is and fill it full of concrete, really, really thick, and reinforce it, and then this will hold to that, and that'll add more mass, and then it won't break the surrounding concrete either. We're just going to let it float. It won't tie in. So, it's been a long road for it, but it's time to get it done. Itching to use the welder.